morning everyone. I am Dr. Hemlata, working as professor in the Department of AAA of St.Joseph Institute of Technology. So today we are going to see problems based on economic dispatch. You know, in power system operation and control, we have economic dispatch and unit commitment in the 4th unit, right? In Anna University curriculum and all the other colleges in AAA department is the main core subject, power system operation and control. In that economic dispatch, it's a very important topic, right? So we can do more research work in the same topic also. So today I'm going to take the economic dispatch problem, the two lambda iteration method. Okay, so in this I'll start with the basic problem, then I'll take all the possible types without the losses, lambda iteration method without the losses. Okay, let me start. So the first problem is the fuel cost of 2 units are given by F1 and F2. It's given if the total demand on the generation is 250 megawatt, find the economic load scheduling of the 2 units. Okay, so the economic dispatch problem without loss, that too the limits are not given. So I am going to start with the basic problem. Okay. So the fuel cost of the first unit, that is F1. F1 is 1.6 plus 25 Pg1 plus 0.1 Pg1 square rupees per hour. Then for the second unit, F2 is 2.1 plus 32 Pg2 plus 0.1 Pg2 square. The unit is rupees per hour. Is it clear? So the F1 and F2, the equations are given. Then total demand on the 2 generators is PD is 250 megawatt. So we have to find out using the lambda iteration method what is the contribution of each unit. Pg1 and Pg2 we have to calculate. Okay. So here this 250 megawatt is going to be supplied by 2 units. That is Pg1 plus Pg2 together it has to supply 250 megawatt. Okay. So it's a lambda iteration method now. So how to proceed further? We have to see lambda 1 that is equal to lambda 2. From this we have to arrive the equation. Then using these 2 equations we have to solve the problem. Okay. So what is lambda 1? Lambda 1 is the first derivative of this equation. This F1 of the first derivative. Okay. So first derivative means F1 dash, that is lambda 1. That is 25 plus 2 into 0.1 Pg1. Like that, from F2 dash, this is the first derivative. That is lambda 2. Lambda 2 means here you have to do the first derivative. That is 32 plus 2 into 0.1 Pg2. Now we have to equate these 2 equations. Lambda 1 that is equal to lambda 2. So 25 plus 0.2 Pg1, that is it from this 32 plus 2 into 0.1, 0.2 Pg2. Just simplify this equation. Okay. So you get 0.2 Pg1. You bring this 0.2 to, the Pg2 to the other side. So you will get minus 0.2 Pg2. This 32, it will be in the same side. You bring this 25 to the other side. So you will get 7. So 0.2 Pg1 minus 1. So you can have this as the second equation. Okay. So you have to simplify the second equation. So equation 2 that should be divided by 0.2. So you get, if you divide this by 0.2, you will get Pg1 minus Pg2. If you divide this 7 by 0.2, okay, you will get 35. So this is the second equation. So first equation, you know, this is the first equation. Then this is the second equation. Okay, you solve these two. Pg1 plus Pg2, that is equal to 250. Pg1 minus Pg2. So we will write these two equations once again. Pg1 plus Pg2, that is equal to 250. Then Pg1 minus Pg2 is 35. Is it clear? First, these are the given equations. Total demand is 250. For this only we have to find out the generation part of each generator. So you are going to use the lambda iteration method. So in that you have to equate lambda 1 that is equal to lambda 2. That is, you have to find out the first derivative of the given equations. So f1 dash and f2 dash we have to find out. Then equate these two. Simplify this equation. Finally, you got these two equations. Now you cancel these two. You will get 2 Pg1 that is equal to 285. Then Pg1 is 285 by 2. 285 by 2, it is 142.5 megawatt. So this is for Pg1. So far we have to find out Pg2 also. So you can substitute this in the equation. So Pg1 minus Pg2 is 35. You know Pg1, you have to find out only Pg2, right? So you bring this Pg1 minus 35, you can bring this to Pg2 to the other side. Okay, so Pg1 is 142.5 minus 35 is Pg2. So 142 minus 35 is 107.5 megawatt. This is Pg2. In this way, you are able to find out what is Pg1 and Pg2. Is it clear? So we have two units, two generating units using the economic dispatch methodology. In that we have so many methods. So here we are using lambda iteration method. Using that method, we have solved the problem. So for supplying this 250 megawatt, the first generator has to supply 142.5 and then the second generator has to supply 107.5 megawatt. So here we are not going to use any operation limits. Generator order limits we didn't see. Just we got the equation, we got the demand, then we have solved the problem. Okay. Then the next problem is we have to consider the limits also. Okay. Okay. Then the next problem is determine the economic generation schedule of the three generating units in a power system to meet the system load of 925 megawatt. The operating limit and cost function is given below. So in the problem they have specified three cost equations. So obviously there are three units and then the corresponding operating limits for each generating unit it's given separately. In the previous problem we saw the generation limit is common for all the three units. But here for each generating unit they have specified the separate operating limit. Okay. So how to solve this problem? So the procedure is we have to calculate lambda first. What is the formula for lambda? PD plus sigma I equals 1 to n with the generating number of generating units, Bi by 2ai divided by sigma I equals 1 to n 1 by 2ai. Okay. So Bi is the coefficient of Pgi, then ai is the coefficient of ai, ai is the coefficient of Pgi square. Okay. Then we have to calculate using the value of lambda, we have to calculate Pg1, Pg2 and Pg3. So Pgi can the formula lambda minus Bi by 2ai. You know, I is the ith unit. Here in this problem we have 3 units. 3 units is given. Okay. So let me write the cost equation. then operating limits, then using the formula we will proceed further. Okay. So first F1 is 0.0045 Pg1 square plus 5.2 Pg1 plus 580. Then F2 is 0.0056 Pg2 square plus 4.5 Pg2 plus 640. Then F3 is 0.0079 Pg3 square plus 5.8 Pg3 plus 820. This is the cost equation that is given in the problem. Okay. Now, above this, we will write the coefficient directly. So, this is A1, B1, A2, B2, A3, B3. So, while substituting the values, it is easy for us. Okay. Then operating limits also it is given. That is, for the first unit, Pg1 is so the first unit, the generation it should be lie between 250 to 450 megawatt. Okay, for the second unit, it is given it should lie between 200 to 350 megawatt. Okay, for the third unit, it is given so the third unit, it should be, the generation should be between 125 to 225. Okay. So this is a complete problem, and then the total system load, the load should be 925 megawatt. So this 925 is going to be supplied by the three units, that is Pg1, Pg2, then Pg3 together. Okay. So now we have to find out what is the value of Pg1, Pg2 and Pg3. For that, what is the first step? We have to find out the value of lambda. Lambda kenna formula? Pd plus sigma I equals 1 to n, then Bi by 2ai divided by sigma I equals 1 to n 1 by 2ap. Is it clear? Now we have to expand this. Pd as it is plus sigma I equals 1 to n. N is, we have 3 units. So I is 1, 2 and 3. So the equation becomes B2 by 2A2 plus B3 by 2A3 divided by, then in the denominator I equals 1 to n. N is 3. So 1 by 2A, 1 by 2A, I is 1 first. So 1 plus 1 by 2A2 plus 1 by 2A3. What is the next step? We have to substitute the values here. Okay. Then I think you are not able to see if I write in the value. So I will do one thing. I substitute the values here. So lambda, for lambda, PD is, what is the value of PD? It's given as 925. So 925 plus B1 by 2A1. What is the value of B1? 5.2. 5.2 by 2 into, formula is 2 into A1. A1 is 0.0045. Right? Plus, then B2 by 2A2. B2 is 4.5. 4.5 0.5 divided by 2 into A2. A2 is 0.0056. Okay, plus B3 by 2A3. B3 is 5.8 divided by 2 into A3 is this one. Okay, A3 is coefficient of Pg3 square. Okay, so 0.0079 whole divided by what is given? 1 by 2A1. So 1 by 2 into A1 is 0.0045 plus 1 by 2A2. A2 is this one, coefficient of Pg2 square. So 1 by 2 into 0.0056 plus 1 by 2 into A3. A3 is 0.0079. Is it clear? So in this way, we have to find out the value of lambda. Okay, use your calculator. Okay, use your calculator and you have to solve this equation, and then you are supposed to get 8.6149. This is the value of lambda. This is the value of lambda. What is the next step? We have to calculate Pg1, Pg2 and Pg3. Finally, we have to check the limits. Okay. So Pg1, what is the formula for Pgi? That is the generalized formula. Lambda minus Bi by 2Ai. 2Ai. So we have to calculate Pg1, Pg2 and Pg3. Right? So what is the formula? Lambda. Okay. Lambda Bi for the first unit, it is B1. B1 by 2A1. First we have to write out the formula. Okay. So lambda for Pg2, it is lambda by B2 by 2A2. Then for Pg3, it is lambda by B3 by 2A3. The next step is we will substitute the values. Okay. So lambda already you got 8.649. So if you approximate this to, so you get 8.62 minus B1. B1 is this one. B1 is 5.2 divided by A1. A1 here is 0.0045. Okay. Then lambda 8.62 minus B2. B2 is 4.5 divided by A2. A2 here is 0.0056. Okay. So 0.0056. 2 into. Then lambda 8.62 minus B3. B3 is 5.8 by A3. A3 you can get it from the equation 0.0079. Okay. 0.2 into 0.0079. Use your calculator. Use your calculator and then calculate this value, and then you are supposed to get 379.4 megawatt. Then for Pg2 it is 367.4 megawatt. Then for Pg3 178.16 megawatt. Use your calculator. You calculate this value. So for Pg1 it's 379.4, Pg2 it's 367.4, then for Pg3 you got 178. So we got the value for Pg1, Pg2 and Pg3. If you add these three values, sure you will be getting 925. That is the total load. Yeah, it's okay. So the generator is perfectly, it is giving the generation. But What's given in the problem? They have specified the limits also for each unit. For PG1, the PG1 it should lie between 250 to 450. 250 to 450. So the maximum is 450, minimum is 250. So it's within the limit. Okay, it's okay. Then for the second unit, the PG2, it should lie between 200 to 350. 200 minimum limit, but 350 is the maximum. But according to our calculation, it's given that it is 365, 367. So obviously it is exceeding the limit. So it doesn't satisfy the limit. Okay, then you check the third unit. The third unit, it should generate the value, the generation value should lie between 125 to 225. 125 to 225. So obviously this is within the limit. So PG1 and PG3 is accepted. It is within the limit. But PG2 exceeds the maximum value. Maximum, what is the maximum value? It's given in the problem. What is the maximum value? It is 350. Above 350, the generator cannot generate, right? For this particular cost equation. So what we have to do now? We have to fix this PG2 as the maximum limit. Because the maximum limit is exceeded. Are you able to understand? The maximum limit is only 350, but it is 367. So it's exceeding only the maximum limit. So what we have to do now, if the particular unit is exceeding, we have to fix up. For that particular unit, we have to fix up the maximum limit, 350. For example, if there is some unit, if it is exceeding the minimum limit, means if the generation is for a particular, for the PG3, if the generation is only 100 megawatt, okay, 100 megawatt, only we got the answer now, it's exceeding the minimum limit. So we have to fix up the PG3 as 125 only. Are you able to understand? If the limits are exceeding, maximum limit is exceeding, we have to fix up the maximum value. If the minimum value is exceeding, we have to fix up the minimum value. But in our case, in here, PG2 is exceeding the maximum limit. So that's why PG2 we fixed as 350. So the final answer for PG2, the final answer for PG2 is 350. So we have to calculate this PG1 and PG3. PG1 and PG3. How to do that? I will erase this one. Okay. So now we have fixed PG2 as 350. So what we have to calculate? We have to calculate only PG1 and PG3 using the lambda equation. So lambda is lambda 1 that should be equal to lambda 3. Lambda 1 that is equal to lambda 3. Lambda 1 and first derivative of this F1. Okay. So first derivative of F1 is here 2 into 0.0045 plus here it is 5.2. That is equal to lambda 3. For lambda 3, 2 into 0.0079 plus 5.8. Lambda 1 that is equal to lambda 3. So you have to simplify this equation. Okay. So if you do so, then you get 0.009. Here it is PG1. Here it is PG3. PG1. Here PG1. You bring this equation to the other side. So you get minus, you have plus 5.2, that is equal to 0.0158 PG3 plus 5.8. Then the next step, you bring the constant term to the other side. So you get 0.09 Pg1 plus, if you bring this to the other side, you get to minus 0.0158 Pg3. 5.8, you keep this in the right hand side. Bring this 5.2 to the other side. So minus 5.2. Okay, so this is 5.8 minus 5.2 is 0.6. This is one equation. What is the other equation? Pg1 plus Pg3. It has to give total. It has to give Pg1 plus Pg2 plus Pg3 is 925. Anna, already we fixed Pg2 as 350. Pg2 as 350. So Pg1 plus Pg3, it has to supply 925 minus 350. 925 minus 350. So this is 575. This is the second equation. Now you got two equations. Okay, 1 and 2. We have to solve these two equations. Then we have to find out the value of Pg1 and Pg3. Okay, so if you do so, you will get Pg1 as 390.5 megawatt. Then Pg3 is 184.48 megawatt. You have to solve these two equations. Only two unknowns, two equations. Okay, solve these two. Then we get Pg1 and Pg3. Already you got Pg2. We fixed the value as 350. So 350 megawatt. Now you check the generating limits. For Pg1 it is 390. So well below the limit. 450 is the maximum. It's only 390. For Pg3 it is 184. It should lie between 125 to 225. So the limits are within the limits. Pg2 is maximum is 350. So the second generator is going to generate 350 megawatt. So now in this problem, according to the given cost equations, given generating limits, given total load, the three generators Pg1 is going to give 390.5 megawatt, Pg2 is 350, Pg3 is 184.48. All the values are within the generating limits. So this is how we have to solve the given problem using the cost equation and the generating limits for the total load, okay, without considering the losses. Okay, so these are the problems based on economic dispatch without considering the losses, okay, using the lambda method. Thank you.